Okay, let's give you guys some more practice. So here, given this here, work out dy by dx of this. Okay, so work out dy by dx here. If you get a graph plotter and plot this, it will look like this red line here. Okay, and again, this red line here stops in the middle of nowhere. And the reason why it stops in the middle of nowhere is because you're trying to differentiate the inverse of cos. And if you look at this here, the inverse of cos, here is only valid within this region here, within -1 and +1 here. This x here is only valid if x is within this region here. Now, if you look at what I gave you here, I'm asking you to differentiate later on. Ultimately, you're going to have to use a product rule, but later on, you will have to differentiate this. And looking at this here, this x here is like you having a bubble here. So the reason why this graph stops in the middle of nowhere is because if you look at this whole thing here, this bubble here is, well, this whole thing here is only valid if this bubble here is within -1 and 1 here. So the bubble is, it's only valid if the bubble is within this range. But well, our bubble here is 2x. So now divide all sides by 2. That's minus a half here and a half here. That's why this region, well, that's why this graph here stops in the middle of nowhere, and this nowhere here is a half, and this nowhere here is minus a half. That's why it stops at minus. Well, anyway, find out find dy by dx of this here. Okay, so you will need to use this bit here, and you need to combine it with the product rule, because the product rule is, well, at the moment you've got this times this block here. So remember the product rule: differentiate this, leave this the same, and then leave this the same, differentiate this here. But then don't forget this here, you've got a chain rule and blah blah blah. Well, anyway, find dy by dx here. Okay, hang on, let me just tidy this up. Okay, so find dy by dx. Okay, yeah. So find dy by dx. So press pause and have a go. Okay, so to do this here, you know you've got to use this here. So hang on. Yeah. So to do this here, if you visualize it as one block multiplying this block here. So you know you've got to differentiate this, leave this the same, and then later leave this the same, differentiate this. So the first step, hang on. The first step is differentiate this, leave this the same. So differentiate the x, that would be 1, and leave this the same. That's this, leaving it the same. Okay, and then plus, and then leave this the same. That's this bit here, and then multiply the whole thing. So you will need square brackets here. Multiply the differential of this, but then for you to differentiate this, you've got to use this thing here. Okay, so immediately jump to this. So when you try and differentiate this thing here, immediately jump to this, and then later on you've got to times the differential of the bubble itself. Okay, so times 2. Well, anyway, hang on, let me start again here. So here, using the product rule, here you've got one thing multiplying with another thing. The product rule is differentiate this, leave this the same. So that will give you this. Now the second part, leave this the same. That's why the x is still the same, and then times the differential of this here. So that will be then this bit here. To differentiate this here, immediately jump to this. Okay, so that will be that will give you this thing here, because the hang on, the notice that, hang on, let me tidy this up. This bubble here is really this bubble here. So later on you've got to get 2x and then square it, That's why you've got this thing here. Okay, you've got this thing here, and then you've got to times the differential of the bubble itself. So that will give you 2. Well, anyway, using the product rule, it will take you to this stage here. So now it's just a matter of tidying up. So here you've got one block, and then you're adding it with this block here. And if you look at this, you've got three things all multiplying with each other here. So you've got this block here multiplying with this block here. So this block here is really a fraction. So this one here gets multiplied to the top. This one here gets multiplied to the top. And don't forget you've got a -1 in there. So that will then become this. So remember the minus here goes here, and the 2 gets multiplied to the top, the x gets multiplied to the top, giving you 2 blah blah blah, and then multiply, square this, that will then give you this. Okay, and then if you get a graph plotter and plot this, it will look like this. Okay, if you get a graph plotter and plot this here, it will look like this. So now have a quick glance to make sure that everything makes sense. So looking at our original red line here, yeah, at this point here, looking at the red line, at this point here, expect a gradient to be 0. The gradient here is 0. Now looking at the blue line here, this point here, vertically downwards here, you can see that the gradient is 0. Okay, so that makes sense. Now looking at the red line now, if around here, you can see that the gradient is really steep, and it's positively steep. So now looking at the blue line, so we're going to have to imagine it to go all the way up here. Looking at the blue line here, you can see that it has a really high positive gradient, so that makes sense. And then now looking back at the red line, let's look at this point here. This point here, you can see that the gradient is negative, and it's quite steep. So now looking at the blue line, and at this point looking at the blue line, which is this point here, well roughly around here, you can see that the gradient is negative. It's in the negative realm, and it's quite steep. So as you move towards a half here, it will become really steep somewhere down here. So well, here you can see that it makes sense. Okay, so yeah, okay.